Okay, so today we're talking about completing the square where a is not equal to 1. I actually want to start with normal completing the square though, just to make sure you understand how to do that. Normal completing the square starts like this. If I had x squared plus 10x minus 11, do you remember how half and square helped? So you do half of 10 is what? 5 squared is what? 25, and this number right there needs to be 25. So I go like this, y equals x squared plus 10x, move the negative 11 way over there, and then put a plus 25 here and a minus 25 right next to it. Then this part right here is perfect, which makes it y equals x plus 5 squared, and then this part right here goes together, negative 36. Raise your hand if you get that. All right, then I want you to try one like it. Y equals x squared minus 8x plus 2. Complete the square so you can get vertex form. Pause for a moment while you do that. And when you're done, I want you to billboard it my way, and I'll tell you if you did it right or not. Okay, so on that one, this 2 got moved away over here, and then I went plus 16 and minus 16. This part right here, x minus 4 squared minus, and then that goes together, 14. Okay, for those watching at home, that's what the right answer was, except I can't apparently make an equal sign. Okay, now what if they asked you for the vertex of that? That'd be pretty easy, wouldn't it? What is it now? 4 comma negative 14. Okay, and then from there, would you be able to tell me if that vertex is a maximum or a minimum? What is it? Normal parabola looks like this, right? Normal parabolas have a what? A minimum. This is a normal parabola. What if you slap a negative out front? Then it would turn that into a maximum. All right, good. Then this kind. Why can't we do this kind like we would have done the one we just did? What's different about it? There's a 4 in front. Can't have that. So here's what you do. You factor out that 4. Now some of you might be saying, but 4 goes into this and this, but it doesn't go into that. That's okay, because we're not going to touch that last term. Remember how we always move that last term way over? That's the first thing you do. To keep yourself from thinking that you got to factor something out of the 17, because you do not. You can factor something out of just the first 2 numbers. That's legal. I know it's different, but it's just think about this. When it's done, when I go like this, x squared plus 4x, isn't that the exact same thing as what I had originally? If I multiplied it back out, isn't it the exact same? Isn't it equal? I can do that. All right, now why is it good to do that? Because now there's nothing on the x squared, and therefore I can make a perfect square again. The goal of this is that this part right here becomes a perfect square. So I need help from a little German boy. Half and square. Half 4 is 2. 2 squared is 4. Plus 4. And if I put a plus 4 there, I put a minus 4 here. But there's a little complication now. Do you remember that the plus 4 and the minus 4 are supposed to cancel each other out? This is a deep thinking question. Everybody shut your iPads for a moment. Because it's not on your screen, it's on mine only. Why, shut the iPad please, why won't those 4s cancel each other out anymore? What did I do different that makes those 4s not able to cancel each other? Yes, sir? This 4 in front is going to times by this 4 right here. Yeah. They would not cancel each other as they are written right now. So, whatever gets factored out to the front has to also be put right there. So that it'll be a, yes, this will turn into a positive 16, so then this will turn into a negative 16. See what I mean? And that right there is the step that I'd say 1/4 of you are going to forget on the test. It's so easy to forget that. By saying that, I'm hoping that I'm going to challenge you into not forgetting this step. You got to throw that 4 in there, and it's really easy to forget. Okay, everybody open your iPads back up again. And the final answer for this guy, 4, and the perfect part is perfect, x plus 2 squared. And then I got to remember this is times by 4. Negative 16 plus a 17 makes plus 1. And now I have the vertex. It's negative 2 comma 1. They actually ask for a bunch of questions here, the green questions, and that's new. You haven't had to do that before, but it's really not hard. Vertex form is already done. We did it. It's right there. The vertex, so that's easy. We usually talk about that anyway. -2, 1. There, done. Max or min. Is this a normal parabola or not? Yes, it's a normal parabola. It doesn't have a negative in front, so therefore it's like this, and therefore is it a max or a min at the vertex? It's a min. And then in the domain, I'll give you a hint. Any parabola has the same domain. Every parabola. Domain is how far will it go this way and how far will it go that way. Every parabola in the world goes from negative infinity to positive infinity. So this domain question is easy. But the range is totally different for each one. And you got to know where the parabola is to be able to do this. So for me, I have to make a picture for my range. And this is what we even do in pre-calc. So you just have to sketch a little picture of it to get the range. So what does it look like? Well, I know it goes at -2, 1. So where is that? -2, 1's like right there. And it's a normal parabola, so it's generally like that. So now I can do the range. Remember, it's how low to how high. And my range goes from what to what? 1 to infinity is correct. And then can it be 1? Can it touch 1? Yes, it can. Bracket. Parentheses. Remember those? All right, I'd like you to try this one. The only trick is there's no number that needs to be factored out, but there's a negative that has to be factored out. How do you factor out a negative? You think of it as factoring out a -1. Okay, so I'll get started here by doing -1 times, and then remember the -94 just way over here. Just move it way off to the side so you don't mix the 94 in with that. We don't need to take the negative off the 94. We're not touching the -94. If I take a negative off the x squared, then the x squared doesn't have anything on it anymore, and that's good. Careful with the 20. It's not plus 20 anymore. It's minus 20x. And now I can do my half and square. Remember to always do the half and square later, because a lot of times you're factoring out a number, and it totally changes what your half and square would be. So you got to do the half and square after you've factored something out. Half of 20 is 10. 10 squared is 100. And if there's a plus 100 here, there's a minus 100 here. And why is this a wrong answer? X minus 10 squared minus 194. It's going to get a lot of people because they're going to be like, looks totally right to me. What part did I forget, Mr. M? Yes, whatever's factored out here has to also be here, because this is going to turn this into negative 100, so this needs to become positive 100. All right, so positive 100 and minus 94 makes positive 6. There we go. Final answer, what's the vertex? 10, 6. Is it a max or a min? All right, is this, yeah, it's a max this time because there's a negative. And it would help to make my little sketch. So I'm going to make my sketch. Here's 10, 6, like right there. And it goes like this time, though. And then I'm going to ask myself, if that's a maximum, what's its domain? Oh, Serber said the domains are always the same. What are they? Negative infinity to positive infinity. And then the last thing is the range. How low to how high? Here's a really common mistake answer. People will go 6 to negative infinity. And they're just positive they're right. And they kind of are. It's just what's wrong with that answer. Negative infinity has to be first. Because your lowest number has to always be first in these. You know, a little interval like that, where there's two numbers with a comma, the lowest number has to be first, and negative infinity is definitely the lowest of all the numbers. So negative infinity to 6, and it's still wrong. What did I do wrong? 6 has to have a bracket because it can touch 6. There we go. Now it's right. Okay, lots of little things, little places to make little half-point mistakes. Just like on the test that you guys just got back. Be honest. How many of you lost a half a point at least for getting the y equals? Almost everybody. Okay. All right, good. So that maxed out at 1 point wrong for that. All right, here's one last one. Do it from start to finish, no help from me. And if I feel like about 80% of the class has got it, then we'll assign your homework, and then you can ask me questions if you get stuck. All right, try this one, number 3. I'll pause for a minute while you do it. All right, so here's how you should have started. You should have taken that 3 out, and then you got x squared minus 8x, and then don't touch the 40. 40 goes to the end. You'll leave room for half and square. Half of 8 is 4. 4 squared is 16. This is a negative 16. How many of you remembered to put this 3 by the negative 16? Raise your hand if you did. All right, if you forgot that, the whole problem is going to be wrong. And then the next part, y equals 3, and then x minus 4 squared. And then this part right here, 30, 63 is 18, 48. Negative 48 plus 40 makes negative 8. Final answer, what's the vertex? 4, comma, negative 8. Is it a max or a min? It's a min. Normal parabolas have a min. There's no negative in front, so this is a parabola. It looks kind of, oh, in fact, I should just graph it. 4 comma negative 8 means that the vertex is way down here, and it's kind of generally like that. And now the domain of it, always negative infinity to positive infinity. And the last question is the range, how low to how high, the lowest number first. And how low does it go? Negative 8. Negative 8 to positive infinity, bracket on the negative 8. How many of you feel like you got this nailed down? Okay, good. Then your homework for today, remember we can skip problems 7 and 9 just to cut it down to a more reasonable size. And you have a fair amount of time to work on homework now. Use it well. And that's all I have for the video for today.